Hello everyone, I'm Samarawickrama from the Department of Geography and International Center for Multidisciplinary Studies, Faculty of Humanities and Social Sciences, University of Jayewardenepura, Sri Lanka. My supervisor is Dr. KDPP Jayasinghe and she guided me for this research. The research titled Urban Center Identification and Ranking Using VIIRS Nighttime Light Data, a scalable GIS-based framework for sustainable planning in developing countries. Let's move to the presentation. Background of this study. Rapid population growth in urban areas has accelerated urban expansion in developing countries. So, identifying urban boundaries is essential for effective urban management and sustainable spatial planning. Accurate identification of urban centers supports infrastructure development and resource allocation. So, this research aims to introduce an innovative GIS and remote sensing based urban center identification and ranking method by integrating conventional urban analysis method with VIIRS nighttime light data analysis. VIIRS nighttime light data will be used to identify spatial patterns of urban intensity and urban expansion. The integration of conventional methods and satellite-based analysis improve the accuracy of urban center delineation. So, the proposed approach contributes to sustainable urban planning and decision-making process. Here is the research problem. Actually, what are the main issues that addressed in this research? Most developing countries still rely on conventional administrative boundary-based methods to delineate urban areas, which fails to capture real urban growth patterns and dynamic expansion. Here is the significance of this study. Why does this problem need to be studied? Because traditional approaches are often insufficient for accurately identifying functional urban regions and require significant time and cost for data collection and analysis. Moreover, they limit the ability to produce reliable future urban growth prediction, thereby concentrating the development of effective and sustainable planning strategies. Because of that, there is a novelty of this research. The novelty of this research can introduce as a single source remote sensing dataset as a rapid and accurate approach for identifying and ranking urban centers with a short time frame, enhancing efficiency in urban analysis. Research objectives. According to the research objectives, the main objective goes as to evaluate GIS and remote sensing methodologies for the identification and ranking of urban centers for sustainable planning. There are several sub-objectives of the research. First one is to evaluate conventional methods for identifying urban centers. Second one is to apply nighttime light data for the identification and delineation of urban centers. Finally, to compare and validate conventional and nighttime light-based outputs and develop a raster-based approach for ranking urban centers. Here is the research framework. According to the research framework, first we have to input data. In this research, we are consider two main analytical parts. So, first one goes with the conventional analysis and second one goes with the nighttime data analysis part. For conventional analysis, we mainly consider about built-up area analysis, road network analysis, service area analysis, population analysis, and road network connectivity analysis. As well as VIIRS nighttime light data also have to be input and processed for going to the process. Second part of this framework is methodology. In methodology part also we have to do two methodological approaches. First one is for the conventional method, and second one is the analysis of nighttime light data. In the analysis part, we have to do spatial overlay and comparison for getting the output, and then check the accuracy assessment, and as the final, do a raster-based analysis. Outputs can be generated urban center delineation maps, rank urban centers, and validate results. Here's the methodology of this research. According to the methodology, first I would like to introduce the study area and of this research. We have focus for southern province Sri Lanka, considering main district Gol, Madra, and Hambantota for this analysis. Data collection part goes with secondary databases. In the secondary data collection part, we have collected some data from sources. For population data, we use open source and collected population data to analyze population distribution and the density. Then goes to the build-up area data. We use global human settlement layer as the data source for download data and identify build-up density patterns. Then go to the collect road network data by using OpenStreetMap, and then analyze road density and UCL depth map used to do connectivity analysis. Then service area data also collected from OpenStreetMap and do assess service availability. VIIRS nighttime light data also gathered from NOAA VIIRS data portal. Administrative boundary data also collected from DIVA GIS as vector polygons. Here is the data analysis part. As I mentioned previously, we have to do two methods for analysis. First one is the conventional method. For conventional method testing, we have to analyze 5 main parameters: population density, build-up density, service area availability, road network availability, and road network connectivity. Based on that, first we have analyzed population data to generate population density map. Then use build-up data for creating build-up density map, and using the analytical technique was the density analysis. Then service area availability checking used for service area data, and the technique applied for this is kernel density, and generate the service area availability map. Road network data we have analyzed in two methods. First one is for analyze the road density, and second one is test for the road connectivity. Here is the research results. As I mentioned earlier, I collected data for nighttime light data from VIIRS data portal. So, first I would like to explain about the VIIRS NTL threshold testing. To analyze the VIIRS nighttime light data, a radiance-based reclassification approach was employed. A threshold technique was applied to the VIIRS radiance values to categorize the data set into 5 discrete classes representing varying levels of nocturnal light intensity for spatial analysis. In here, we have classified 5 urban areas based on the intensity level. Those are rural, semi-urban, peri-urban, urban, and high urban areas. Here I attach some maps that created within the selected time period, and it shows the correct variance of the intensity based on the classification. Here is the conventional method results. In conventional method, mainly generated thematic density maps for population density, road network connectivity, service area availability, and built-up density. Here also there are two maps that represent within the specific time period about the urban area distribution analysis that have done by using the conventional method. Here we used the reclassification methods and weighted overlay methods. First, we classified all output layers into 5 standard classes and then normalized spatial datasets for uniform comparison. After that, applied weighted overlay analysis to integrate all 5 parameters. Then produced a composite urban suitability map and used the final output to identify and delineate urban areas based on the conventional GIS approach. Here is the final result that can as the comparison map urban concentration patterns and urban hierarchy with the study area, and highly urbanized areas showed the strong brightness value in VIRS NTL outputs as well as high densities in conventional GIS analysis. This research identified a strong spatial overlay between VIRS NTL outputs and conventional GIS-based urban identification results. This confirmed that VIRS NTL data can be considered a reliable single source dataset for urban delineation. And then the methods demonstrate high spatial accuracy in identifying urban extents and urban intensity level. Furthermore, the study supports the development of an urban center ranking framework using GIS techniques for suitable urban planning and development. Here is the references that I used for this research. And this is the end of my presentation. Thank you all.